Good morning, good afternoon, good evening, dear friends and colleagues of our IFES, GDC, and IUCE community. I'm very pleased that you're joining us, and it's particularly I'm very pleased to introduce a new colleague, Professor Alireza Taheri, who is an assistant professor of mechanical engineering at the Sharif University of Technology in Tehran, Iran. So I'm very pleased to have a colleague from Iran, from Tehran, with us. Professor Taheri is the head of the Social and Cognitive Robotics Lab at Sharif University of Technology. And his research that he's undertaking is very fascinating, of a lot of personal interest to me also. His research focuses on designing using intelligent robotic systems for education and rehabilitation of children with special needs. And that's a very fascinating and a very important topic. So Alireza, Professor Taheri, I'm just very pleased that you're with us. I appreciate it, and I leave it in your able hands. Please begin your presentation.
Thank you very much for the introduction. Hi, everyone. Thank you very much for inviting me as a speaker. It is wonderful to be here. My name is Alireza Taheri. I'm an assistant professor at Sharif University of Technology and the head of the Social and Cognitive Robotics Lab. Let me turn off my camera in order to save some bandwidth for better internet connection. And let me share the screen. Please let me know whether you have my screen right now.
Yes.
Is it okay?
Yes, yes, it is there. Thank you.
Good. So on behalf of my colleagues and my friends, I would like to start my lecture entitled Impacts of Social Robots on Improving the Quality of Life in Children with Special Needs. For the beginning, let's see this video. This is one of the last group photos in our lab. You can see the students, professors, and also our design robots. Professor Ali Meghdari, Professor Minu Alemi, and I are supervising the projects. Here you can see the graphical outline of my talk. Actually, the main line of our research focuses on designing and using social robots, virtual reality systems, and human-robot interaction platforms for education, rehabilitation, and entertainment of children with special needs, such as children with autism, children with cancer, individuals with hearing problems, children with dyslexia, and so on. We really love working in the field of improving the quality of life of individuals with special needs. Our works can be grouped into three main parts. The first part is robots design and fabrication. The second is working in the intersection of using modern AI and control algorithms to empower our robots. And the last part is conducting acceptance and educational or clinical intervention sessions for our users. Let's have a definition of social robots. A social robot is an entity that can not only sense, think, and act, but also must be able to communicate with humans or other social robots. Social robots could be super interesting assistive tools for education, rehabilitation, and entertainment. To have a better understanding, let's see a short video of some social robots in the world. This is the Bandit from University of Southern California. This is the Body Robot. This is an animal-like robot to interact with people in the hospital. This is Isoy, interactive children with autism. This is the Face Robot. This is the Flash Robot with more than 50 degrees of freedom. It is Infanoid made by Cosimo in Japan.
Sridhar, I am not hearing anything. Can you hear me?
Yes, I think his internet froze.
Hello, Alireza? Alireza?
Yes, disconnected. We'll look for him to join back.
Okay. Thank you, Aliki. Good morning, Aliki.
That was a good message. Thank you so much.
Yeah,
Greetings, everyone. As we wait for our presenter to join back, please introduce yourselves in the chat and tell us where you're connecting from.
yeah, wonderful idea, Aliki. Oh, we have another colleague from Professor Zara from Tehran. Wonderful.
Hi again.
Oh, I'm glad you're back.
I think I was disconnected.
Yes. Please go ahead.
Sorry. So again, I share my screen. Do you have my slides right now?
Yes.
Please let me know. Thank you. So let's continue with this slide. Let me present our works in autism area. Autism spectrum disorders is a lifelong developmental disability which affects the way a person communicates to people around them. Researchers have reported that children with autism usually work naturally with technologies, so social robots might be good educational tools for them. I started working in this field about 10 years ago when I was a PhD student. It is mentioned in the literature that music-based clinical interventions could be effective for cognitive rehabilitation of children with ASD. In one part of our previous research, we decided to empower a commercial robot called Now to play a musical instrument. As you see, we chose a xylophone. It is the Happy Birthday Funk.
خیلی خوب بود.
This is a gift to whom their birthdays are around today. In this slide, you can see a short video of one of our robot-assisted clinical interventions for education and cognitive rehabilitation of children with autism during a music-based program.
گوش بده رادمی قشنگ مثل نیما یه بار دیگه نیما بلده. نیما ببین اینجا 2 آبیه. تو میدونی اسم این آبیا چیه؟
به این میگن
دو آبی اسمش چیه؟
In this study, we observed some improvement in joint attention and in imitation skills of both the high-functioning and low-functioning subjects with ASD. It was observed that the high-functioning children's social skills improved due to the robot-assisted therapy sessions, while the stereotype behaviors of the low-functioning subjects decreased somewhat during the course of the program. In another study, we designed a human-robot facial expression reciprocal interaction platform. By using AI algorithms, the robot was empowered to recognize the facial expression of the children automatically. It could also assess the children's performance automatically too. The robot's name is Alice by Robokind Hansen Company. We called it Mina, an Iranian name for girls. We recruited 14 children with ASD to have a communication with the Alice robot. We observed that the Pearson's correlation factor R was equal to 0.9 between the automated and manual scores. which shows that assessing imitation skills of children could be handled by robotic platforms. Moreover, we used virtual reality technology to educate children with autism. We designed a virtual room for children with ASD using virtual social robots, virtual xylophone, and
به
virtual drum.
ترتیب رنگایی که بالای سر من میبینی و بزن. تو چقدر واردی؟
In a study, we recruited 20 typically developing children and 20 children with ASD, and we observed significant differences in different performances of the children in these virtual reality-based games. This is another study in which
بگو اسمشم بگو آره.
the children with ASD was hired to participate in a study,
بگو می
in a music-based study. In this study, which contains using virtual reality robots for teaching music to children with ASD, the effectiveness of the proposed method was proved by conducting a statistical analysis on the child's performance data during the music education sessions. Our next idea was using robots for education of children with cancer. In the cancer study using social robots, the results indicated that the children's stress, depression, and anger were reduced during the social robot assisted therapy. You can see the robot teaching children with cancer as a nurse.
اینجوری بچه‌ها بخندید. اینجوری؟ حالا بخندید شما دکترها همکارین؟ آقای پرستار نیما؟
معلومه که درسته. یادتون هست آقای دکتر گفته که براتون داروهای خوب و قوی می‌نویسه که آروم آروم حالتون رو خوب کنه؟
یادتونه بچه‌ها؟ یادتون نیست؟ آقای دکتر نیما گفته بود. خب بچه‌ها
And after that, after observing positive results from commercial social robots, next we decided to design and fabricate our own social robots in the lab. The first robot I want to introduce is the Arash robot to be used in pediatric hospitals. You can see the time lapse of designing and assembling this social robot. And now let's see the performance of the Arash robot.
اسم من آرشه. من یه ربات کمک درمانگرم که میتونم با بچه ها مخصوصا بچه های بیمار دوست بشم. میتونم باهاشون صحبت کنم و به حرفاشون گوش بدم. من میتونم نقشه مختلفی بازی کنم مثل یه معلم، دکتر و حتی یه بچه. هدف من کم کردن استرس بچه ها و پدر مادراشونه. در کنارش میتونم یه سری چیزا بهشون یاد بدم مثل رژیم درست غذایی، مراحل درمان بیماری و هر چیزی که از من خواسته بشه. امیدوارم بتونم دوست خوبی برای بچه ها باشم و از ته دلم آرزو میکنم که هیچ بچه‌ای مریض نباشه.
Studies show that children with cancer experience emotional distress during their treatment and chemotherapy, and this distress can reduce the efficiency of the treatment, and our goal is to decrease this distress. In our previous study, we used a commercial robot to evaluate the influence of using robot in distress management of children with cancer. Several factors like level of anxiety, depression, and anger were decreased, and these results encouraged us to construct a domestic robot for this purpose. Robot has 15 degrees of freedom. It's a cost-effective humanoid mobile robot, and it's designed and constructed to interact with children ages from 4 to 12 years old. It has several interaction modules like facial expression recognition and imitation, sound source localization, and so on. And also it operates on ROS. One of the most important design criteria was the robot appearance, which is selected based on a survey taken from 50 children with chronic disease at 3 hospitals, Mahak, Mofid, and Shohada hospitals in the city of Tehran. Based on these aspects, we designed, constructed, and modified the robot to operate in the hospital's environments. After the completion of the robot, we went back to hospital to conduct some experiments. We evaluated the level of children's acceptance and involvement with the robot. We assessed their feelings about the robot, and we measured how much the selected sketch is similar to the constructed robot.
مامان موشا هم رفته بود بیرون که برای بچه‌هاش غذا بیاره. همون موقع بود که رسید دم در خونه. اون برای اینکه به خونش برسه مجبور شد که آروم از روی دم شیر رد بشه. اما یه دفعه شیر بیدار شد و پرید و اونو گرفت. مامان موشا خیلی ترسید.
The experimental results overall indicate that Arash was a true success among children with cancer in hospital environment, and we hope to use Arash in hospitals all over the country to alleviate the pain and difficulties that children with cancer face during their treatments.
And our next robot is the Maya robots. It's an animal-like robot which is designed to be used in pediatric hospitals. Its shape is an elephant. It has 5 degrees of freedom. Let's see a short video of this robot. This is
هستم.
robot is introducing itself.
من قابلیت‌های مختلفی دارم. میتونم با بچه‌ها ارتباط برقرار کنم، اونا رو ببینم، احساساتشون رو تشخیص بدم و به حرفاشون گوش کنم. امیدوارم خیلی زود بیام پیشتون بچه‌ها. خداحافظ.
The next robot is the Rasa robot. Rasa robot has been designed and developed at Sharif University of Technology to interact via Iranian Sign Language with children with hearing problems. We implemented some Iranian Sign Language on the Rasa robot. You can see its performance. We implemented a gaze control system on the Rasa robot. This system takes some important verbal and non-verbal social cues into account, and at each moment enables the robot to decide socially and humanly to direct its gaze. you can see the Rasa 2, the next version of the Rasa robot. Interact with children via Iranian Sign Language. He's saying, "Hi, my name is Rasa." People can teach Rasa new Iranian Sign Language or any other sign language. Using this block. Including some IMU sensors. We conducted a study to teach Iranian Sign Language to children using Rasa robots.
Rasa is a social robot designed and developed in Sharif University to facilitate teaching ISL to deaf children. Having 32 degrees of freedom, including 7 in its active fingers, enables Rasa to interact with users using ISL. To teach a new sign to Rasa, the teacher needs to wear the data glove and perform the sign to pass the corresponding word to the robot. The pre-trained neural network converts the sign to an embedded vector. We have implemented a learning from demonstration structure for teaching new ISL signs to Rasa. This LFT architecture utilizes one-shot learning technique and convolutional neural network to learn to recognize and imitate a sign after seeing its demonstration just once. The expansibility and promising results of the one-shot learning from demonstration technique in this study are the main achievements of conducting such machine learning algorithms in social HRI. Rasa captures uses hand gestures with a data collection glove. The glove transmits positional and rotational data of the hand and the fingers to Rasa using multiple IMU sensors. Then the data are collected, pre-processed, and finally transmitted to the recognition module. And a state image approach was implemented to convert these data into pictures that can be fed to a deep neural network. Rasa uses an adaptive teaching architecture to perform ISL teaching to users, having different modules including robot output generator module. This architecture helps Rasa to adapt its behavior, including the performance speed, the emotional reaction, and the repetition number, based on the user's past history and present performance in a manner similar to a human teacher.
After conducting our Rasa-assisted sessions for educating Iranian Sign Language, a statistical analysis of the t-test and Cohen's d effect size found that the users felt the robot's adaptability in education very well. And this is the Taban robot for educational children with dyslexia.
I'm doing well. How are you? Oh, we'll be out by 11. Like, probably before 11 o'clock. Yeah. I do. I was just going to make that in the queue with the phone calls. Oh, no, it's still there right now. Right. video call, yeah. Thank you. No problem. Thank you so much. Yeah, okay.
راست میگی؟ آره اشتباه گفتم. شاید یکم بیشتر فکر کنم. آره فهمیدم. ما با ما مثل همه. آفرین.
In one of our study for using robots for children with learning disorders, the acceptance of the Taban robot was studied during some intervention sessions. The acceptance of the robot was compared with the tablet technology through a storytelling task. We indicated that in our experimental setup, the robot storyteller's scores were higher than the tablet for both the typically developing and dyslexic group in all of the questionnaires by them. We also designed virtual reality-based games for Taban 2. Users can use the VR headset and do the virtual robots tasks in the game. And to wrap up, we can conclude that modern technologies like social robots as assistants or tools are going to have a significant impact on teaching, learning, and pediatric care and rehabilitation. The power of modern and more intelligent devices are going to make anytime, anywhere learning more routine and accessible. With the design and development of low-cost educational tools, the role of up-to-date educators and healthcare specialists are going to become more important than ever. Ethics and morality issues play an important role in using social robots or modern technologies, especially in education and healthcare, and it needs to be addressed. And finally, societies must be consciously prepared for entering the new human-robot world. And that's it. This was my presentation. I hope you enjoyed it.
Thank you so much. This was one of the most creative, fascinating presentations that we've had as part of our webinar series. And I deeply thank you and your community at Sharif University in Tehran for sharing this. And as a father, as a grandfather, some of the issues that you've touched upon, not just intellectual, but also personally, very, 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 very fascinating. I just want you to know that. And I just want you to know how grateful I am for this presentation. And we will share this. We have a recording of it, and we will share this presentation more widely so others can also have the opportunity to learn and to listen to it. Before, I know there will be some questions, and my dear friend and colleague, Professor Gajanan, had a question, but I wanted to ask you just one question before others comment here and question. What is the relationship of the School of Engineering, for example, with the School of Medicine? You know, because of the complexity of the issues. Could you just comment on that and what are some of the challenges and issues there, dear Alireza?
First, I want to appreciate it. It was very kind of you talking about my presentation right now. Sure, feel free to share it with your colleagues and friends. It was a great challenge, but I and my previous professor were very extrovert person. So we are very okay to build some bridges between different sciences, and we decided to work in this field using engineering knowledge for helping people and improving the quality of life. So we needed to learn more about children, to be familiar with pediatric hospitals and so on. So it was a challenge, but it was very sweet for us to do that.
Well, thank you very much, dear Gajanan. Please go ahead. I know you raised have some questions that you'd like, and there are others, and I'll send them through our chat box, please, and we can read those questions. Go ahead, please, Gajanan.
Nothing special. I just was wondering, because we had a lot of students from.
Speak up a little louder, please.
We had a lot of students from Iran at the Harvard University, where I was a professor in civil engineering. So I was just asking him if he had come across anybody from Harvard University returned to your university. That's what all. Thank you.
Did you hear his comment, Alireza?
I missed some parts of his questions. Would you please say it again, or
repeat a little louder, dear Gajanan? Yes. Thank you.
All I'm saying is I was a professor at Harvard University in Washington, D.C. And we used to have a lot of students from Iran, but I have retired for the last 15 years. So do you have any interaction with any professors, faculty from Harvard
out
University
of the country?
in Washington?
No, not Washington. I was a visiting student when I was a PhD student at Yale University in Connecticut, in Connecticut State, in New Haven City. And also in University of Denver, in Denver, Colorado.
Okay.
Each one for 6 months, yes. But no, I haven't any relationships with the professors in Washington or New York.
That's all I had. Okay.
Yeah, thank you. Aliki, do we have any other questions, any comments of our colleagues who are joining us today?
We have one comment. Thanks a lot. Truly holistic approach for benefits of society, which I agree.
Thank you very much.
Very, very good. Thank you. Any other questions before I make a couple of final comments? Any other questions? Aliki, do you see any? I don't see any. Do you?
Not at the moment. If anyone in the audience has any questions, please feel free to either raise your hand or drop the question in the chat, and we will share it with Dr. Taheri.
Wonderful. I'm just sensitive of the time. I just want to make, first of all, Alireza, this has been quite a very unusual and a positive, creative presentation, and that I'm learning a lot, and I will share it, as I said, personally.
That's kind of you. That's kind of you.
And professionally with a lot of colleagues. Let me just, because I'm just looking at a number of colleagues that may not know our IFES GDC community. I just want to make a couple of comments to let you know that we have this year our annual global conference in Mexico at Monterrey Tech, and many of you, we are in close contact in all 6 continents with members of our community. We would love to see you. Even also, there's an opportunity to still submit your papers to join us, per se. Just want you to know that. And this is in October, late October of this year, per se. And also for some of you, I know the GDC, we're in discussions, we're planning our industry, GDC Industry Forum in China, coming back. I was just recently in China and Hong Kong, planning in January our conference of the Global Engineering Deans Council and the Industry Forum, per se. I'm also very, very pleased we had the chance this week at the ASCE conference here in Baltimore, close to Washington, D.C., to engage with many friends and colleagues from throughout the world And we were able to focus and have a very exciting session on our book series of Rising to the Top, written by women engineering leaders throughout the world. And we are still working on 2 volumes focusing on the MENA Arab world and also Southeast Asia over the next few months. I just wanted to all of you to let you know. So I just really want to Alika, I assume there are no other questions, right, that I'm not seeing, correct?
I
No.
cannot see any other questions.
Well,
in the chat box.
Alireza, thank you so much for your very thoughtful and innovative presentation. It means a lot to me personally and to all of us. And let us stay in touch moving forward. All the very
Appreciate
best.
it. And thank you again for inviting me as a speaker, and also from Iranian Society of Engineering Education. I would like to thank them very much for their kind talk to me. So, and I really appreciate it if you can share the recording video with me too.
Okay, we definitely will. Thank you so much, and all the very best to all of you. Thank you for joining us. Peace be with you, and stay healthy, all of you. Bye-bye. Peace be with you.
Thank you and goodbye. Take care.
Bye-bye. Bye-bye, everybody.